Okay, this is the answer key video for the density practice problems. Okay, before we get started here, I thought I would give you kind of my keys for success with all word problems, especially in chemistry course here. Okay, so I'll write them at the top here. I call them my keys for success. All right, so key for success number 1 here. When you are reading these types of word problems, it is always going to help you to draw a picture. Okay, so if you draw a picture, you're going to have a better idea of what is being asked of you and what truly you have. Okay, and along those lines there, key for success number 2 is have an inventory. Okay, so have an inventory, and by that I mean take account of everything that you're given in the problem and everything that you know off the top of your head that could potentially help you solve this problem. All right, and then key for success number 3 is, of course, going to be keeping track of your sig figs. All right, and decimal places. All right, most of the time we're not going to see a lot of decimal place-based problems, but I like to throw that in there for the occasional addition and subtraction problem. All right, so again, those are kind of my keys for success with these word problems. All right, now I'm going to walk you through these problems. I'm going to follow my own keys for success here, and I apologize. I'm going to use a bunch of colors. That's just how I keep track of different things. All right, so first off here, if we read it, a 22.4 gram sample of a substance was added to a graduated cylinder. It caused a 18.3 milliliter change in the volume of the water in the cylinder. What is the density of the substance? Okay, so first off here, I'm going to draw my picture. So again, I'm not the best artist in the world, so I don't expect you to be either. These pictures are solely for you. Okay, so this is my graduated cylinder here. What it's saying is that a substance of 22.4 grams was added, and if let's go with my liquid line started here and ended here, I had a change or a delta of 18.3 milliliters. All right, so 18.3 milliliters. All right, so then next what I'm going to do is I'm going to take my inventory, and you can take inventory wherever you want. Might be easiest for us if I keep it on the right-hand side. Okay, so first off, if we're dealing with density equals mass over volume. Okay, so that is an inventory that we have. That's the equation we need to use, right? We are also given the mass of our sample at 22.4 grams, and we are actually given the volume of our sample based on the displacement, right? So the 18.3 milliliter change in volume is telling us what our volume of our substance actually is. So when I go to plug into my equation, density equals mass over volume, I simply plug in 22.4 grams over 18.3 milliliters. And when I plug this into my calculator, density equals 1.22 grams per milliliter. And that is going to be my final answer for that. Okay, and again, I can check a bunch of things here. First off, I'm going to check sig figs. So there's 3 sig figs on top, 3 sig figs on bottom. Okay, so I'm kept consistent with my sig figs. All right, and then finally, their units. Density is either reported in grams per milliliter or grams per centimeter cubed. So those are the 2 you're mostly going to see density in. So if my answer is in that type of unit, then I'm good to go on to the next problem here. Okay, so that one's pretty simple, hopefully. All right, moving on to question 2 here. A 250 milliliter sugar solution has a density of 1.37 grams per milliliter. An additional 30 grams of sugar was added to the solution and raised the volume by 24.6 milliliters. So what's the density of our resulting sugar solution? Okay, so there's a lot of things going on in this problem. So if we draw our picture here. Okay, if I start it off, okay, my sugar solution in here has a density of 1.37 grams per milliliter originally, right? 1.37 grams per milliliter originally, okay? And it has a volume of 250 mils, all right? It has a volume of 250 mils. Now, the question is, how much sugar do we have in this originally? Right? So if I were to call this volume 1, right? The question then is what is mass 1? Because the very next thing says we're going to add 30 grams of sugar. So that's our mass 2. We're adding 30 grams of sugar, and we're going to raise, right? We're going to raise delta to 4.6 milliliters. Okay? So what we've got to look for is we've got to look for a total volume and a total mass, right? So those are the two things we're looking for, a total volume and a total mass, all right? So my volume total is going to be my 250.0 mils originally, and I'm going to add my 24.6 mils from my change, right? So I went up by that amount, okay? So my new total volume is going to be 274.6 milliliters, right? And this is why I threw decimal places in there, because again, both of these have one decimal place, so we had to keep that consistent. Now, when we're looking for our mass total, okay, we know what mass 2 is, but we don't know what mass 1 is. So mass 1 is still unknown to us, but we know that we're going to add an additional 30.0 grams of sugar, right? So before we can really do anything, we've got to solve for mass 1 here, okay? And we can solve for mass 1 because density equals mass over volume, right? Therefore, mass is equal to density times by volume. And we knew our original density from the problem, that 1.37 grams per milliliter. And we knew our original volume, which was 250 mils. Okay, so when I plug this into my calculator, I'm going to get out my mass 1 as 342.5. All right, 342.5. Okay, and I'm going to end up with 3 significant figures because my density had 3 sig figs and my volume had 4. So mass 1 is actually equal to 343 milliliters. Or I'm sorry, apologies, grams, because my milliliters cancel up here. All right, so that is my new mass. All right, so then I'm going to come back over here and plug that in. So my mass total now is the original 343 grams plus my change of 30.0 grams. All right, so mass total is equal to my 373 grams. Okay, so now I have my new mass, I have my new volume, and I can do my density calculation, right? I can do my new density, or density 2. So density 2 is equal to mass total over volume total, which is equal to 373 grams over 274.6 milliliters, right? So my resulting answer, plug that into my calculator here, I get out an answer of about 1.36 here, right? And I end up with 3 significant figures, all right? I end up with 3 significant figures on that one, okay? And that is grams per milliliter. All right, so that is my new density. All right, that is my new density in blue. Okay. All right, and again, to walk you through that problem, since we added something to our original, we had to figure out what our original mass and what our original volume was. Okay, and once we did that, we then added those together with our change, right, in order to get our new total so that we could calculate our new density. All right, working our way on down here. Okay, it says a material will float on the surface if a liquid of the material has a density less than that of the liquid, right? We know that, right? That's why ice floats on top of water. Okay, given that the density of water is approximately 1.0 grams per milliliter, will a block of material have a value or having a value of 1.2 times 10 to the fourth inches cubed, weighing 350 pounds, float or sink when placed in a reservoir of water? Okay, so essentially what it's asking us here is, if this is my reservoir and I have a density of water of 1.00 grams per milliliter, the question is, if I have a block here and I know that my block's volume is 1.2 times 10 to the fourth inches cubed, and my mass is 350 pounds, right? Will it sink or float? So clearly we're going to solve for density here, right? But before we can do that, if you noticed, the units are not the same on this one. So the units are not the same. So we're going to have to do some quick conversions here. So if my volume is equal to 1.2 times 10 to the fourth inches cubed, I have a conversion between inches and centimeters, but notice it's not just inch to inch, it's inches cubed. So I'm still going to write my conversion of 1 inch over 2.54 centimeters, but again, it is inches cubed. So I'm going to take this entire thing and I'm going to cube it. So when I throw that into my calculator, I'm going to type in 1.2 times 10 to the power 4 times by 2.54 cubed, right? By 2.54 cubed. Okay, and I'm going to get a resulting answer that is really, really long, okay, and I'll write it out just for show here, okay, but obviously, you know, we need to keep sig figs consistent, so I'm going to end up with 2.0 times 10 to the fifth centimeters cubed as my number of sig figs and my proper unit. All right, now when I'm looking at mass, I have 350 pounds, all right, and I know that a conversion between pounds and grams is possible, so I'm going to search that into Google, and I found out there's about 54. Did I just say 354? I'm sorry, I meant 453, okay, grams per pound. All right, units cancel with that. When I plug it into my calculator, I'm going to get out a very large number again, grams, which rounding to proper sig figs is going to give me 1.6 times 10 to the fifth grams. Okay, then this simply becomes a plug and chug problem. Density equals mass over volume. So it equals 1.6 times 10 to the fifth grams over 2.0 times 10 to the fifth centimeters cubed. All right, my final answer for this here is 0.80, just to keep those two sig figs consistent, grams per centimeter cubed. All right, so that is the density, but that is not what the question asked us. It asked us, is it going to float or sink when it's placed in water? So our final answer is that the object will float. Okay, and it will float because its density is less than that of water. All right, its density is less than that of water because the density of water is 1.0 and the density of our object is 0.8. Okay. Now, if we look at number 5 here, a rectangular block has these dimensions, okay? A block has a mass. What is the volume and density of the block? Okay, well, first off, we're going to draw ourselves a beautiful, lovely box here. Okay, and when we're dealing with blocks or cubes or whatever, okay, we know we're going to have to calculate the volume, and it's going to be length times width times height, all right? And the only thing that I am given is, sure, I'm given the dimensions, 2.9, all right, 3.5, and 10.0. All right, and I'm also given that the mass of the block is 615.0 grams. Okay, so first off, I need to solve for volume, and volume is length times width times height. So volume is going to be equal to all of those multiplied together. Okay, and my resulting answer is going to have 10 significant figures. So my volume, 2 significant figures. All right. centimeters cubed, which is going to be shortened to 1.0 times 10 to the second centimeters cubed. All right, that's going to be my volume. All right, that one was specifically asked for right there. Okay, now density is going to be another plug and chug problem. Okay, so density is equal to mass over volume. Our mass is consistent, 615.0 grams over our volume of 1.0 times 10 to the second centimeters cubed. When I plug that into my calculator, I get out in proper sig figs 6.2 grams per centimeter cubed. All right, that is going to be my final answer right there. Okay. Moving on down here, it says diamonds are measured in carats, okay? And then we have the density of our diamond, and it's asking for volume and density, okay? And obviously that one's a mistake. The density is given to us, so we don't have to report that out there, okay? So if I were to draw a picture of relatively what a diamond looked like, sure, right? This diamond is 4.5 carats. And we already know we have a density of 3.51 grams per centimeter cubed. Okay, so our mass here, we have to convert. So mass is equal to, we've got our 4.5 carat diamond, and the conversion between carat and grams is that 1 carat equals 0.200 grams. All right, plug that into our calculator, and reporting out in proper sig figs is 0.90 grams. Okay. So what it should have asked us here is what is the density and mass, right? So that would have been your mass here. Or sorry, what is the volume and the mass? All right. Now, we're not doing our traditional density calculation. We're looking for our volume. So our equation gets modified a little bit. Volume equals mass over density. All right, still a plug and chug problem. So I have my 0.90 grams over my 3.51 grams per centimeter cubed. Okay. When I plug that into my calculator, I get out a volume in proper sig figs of 0.26 centimeters cubed. And that is my final answer. Okay, so my diamond weighs 0.90 grams and it has a volume of 0.26 centimeters cubed. All right, looking at the next one here, the density of pure silver is given to us. If 5.25 grams of pure silver is added to a graduated cylinder containing 11.2 mils of water, what volume level will the water of the cylinder rise? Okay, so this is a multi-layered question here. So first off, let's figure out what it is asking us or what it's telling us to start with. Again, this is my graduated cylinder. Okay, and it contains liquid. All right, its original volume here is 11.2 milliliters. All right, 11.2 milliliters. And I'm going to add my silver pellets, 5.25 grams. All right, so I'm going to add those in there. And it's going to cause my water to rise. Okay, and it's not asking what's the volume of water. It says what will the level be. Okay, so to what volume level will the water rise? Okay, so it's not asking for the change in water. It's asking what's that final. Okay, so if we look at this here, all right, let's start off with what we know. Okay, we know our volume and we know our volume, we know our density. Okay, so if I were to write this under here, the density of those silver pellets was 10.5 grams per centimeter cubed. Okay, so I'm given density of the pellets and I'm given the mass of the pellets. So I need to figure out what my volume is of those pellets here. So volume is equal to mass over density. All right, so I'm going to put in my mass of 5.25 grams over my density of 10.5 grams per centimeter cubed. Okay, my volume's going to be in proper sig figs, 0.500 centimeters cubed. Okay, so that is what my volume of my pellet is. Okay, and hopefully you remember this, if I didn't already say it. Okay, 1 centimeter cubed is equal to 1 milliliter, right? 1 centimeter cubed is equal to 1 milliliter. So this pellet is going to cause a change in about half of a mil, right? It's going to cause a change in about half of a mil. So in order to answer this question, okay, we take our original volume of 11.2 milliliters and we add our half a mil to figure out what the final volume level will be, right? So when I add those together, sorry, just for full clarity, okay, so my volume level is going to be equal to 11.7, all right, 11.7 milliliters. Okay, and again, 1 decimal place because it's an addition-based problem. Okay, so our final answer there is 11.7 mils. All right, final question here for number 8. The density of osmium is given to us, right? It's got a rectangular block, has 2 dimensions. Calculate the third dimension. So again, we're dealing with a rectangular box. So I'm going to draw my rectangle, right? I've got my height, length, width. I know my volume is going to be length times width times height, right? I know that. Okay. And I'm also given 2 of those already, 4 and 4, and I'm given my density of 22.57 grams per centimeter cubed. Okay. So if I'm looking at this here, I need to figure out, oops, sorry, and one more thing. I'm given my mass here of 1.00 kilograms. All right. Now, I need to figure out, obviously, what my volume is going to be based on density and mass. But before I can do that, notice that my mass unit is in kilograms. So I actually have to convert that to grams, which is pretty easy. It's just times 10 to the third grams. All right, now that I have that, I'm going to calculate the volume of this box. So that's going to be my mass over my density. I'm going to plug in my 1.00 times 10 to the third grams over my density of 22.57 grams per centimeter cubed. All right, my new volume here is going to be 44.3 centimeters cubed. Again, keeping my sig figs consistent. Okay. Now that I have that, I know that volume is equal to 44.3 centimeters cubed, and that is equal to my length times my width times my height. So 44.3 centimeters cubed is equal to, I've got 2 of those dimensions already. All right, and I'm trying to solve for the last one here. So if I divide both sides by those the 16 centimeters, all right, I am left with a last dimension. I'm making it my height dimension, 2.77 centimeters. Again, keeping my sig figs consistent. All right, so that third dimension there is that 2.77 centimeters. All right. Again, hopefully this was really helpful for you. Again, these problems are very similar once you understand the process. Okay. But again, my keys for success are draw a picture, have an inventory, and keep track of your sig figs and your decimal places.